Today we're going to be building a simple reaction time testing game with our breadboard components. We're going to need a green LED, a red LED, 4 220 ohm resistors, a active buzzer, you gotta make sure it's active, a button that you click down like this, a microcontroller, I'm using the Uno R3, a breadboard with 2 small wires set up like this, positive rail connecting to positive rail, negative rail connecting to negative rail using small wires, and finally you will need 6 medium-sized wires. And don't forget the cable that comes with your microcontroller. Let's get started. Pushing all our parts to the side, let's get the breadboard into the view, and now let's get started. First and foremost, we're going to want to set up our lights. We're going to just turn the breadboard like this. We're going to want to set the positive ends and the negative ends in the same direction. So the positive end of a light is the longer stick, is the longer leg. So you see this top one is the positive end, and this short one is the negative end. Let's make the positive end face towards the camera, like so. Doing the same with the negative end on the other side. Make sure it's on the other side of this line. Positive end is facing you guys. Let me just do it like this, it looks a lot better. Now, let's connect our resistors. So we have 2 220 ohm resistors for now. Let's bend this one because I took this out just now. Okay, let's use this one and connect our red light directly to the negative end on the power rails. So as the positive end, let's connect the negative end to of the power rails. Actually, let's do this, like this. Let's repeat that exact step on the other side. Let's put this there, and that, and there. There we are. Now just to check if we did it properly, yes, negative is going into negative. Negative is also going into the negative. Nice. Now, 2 wires. 1, 2. Let's connect the positive end, the long end of our lights, like this. Let's do the same on this side. Slot that in right there. Now, let's take these 2, plug them into our microcontroller. Oh, the camera's shaking. Just slow that down. Now you have the red LED's positive wire. Let's connect this red LED positive wire into pin number 2 on our microcontroller. So right here. Now for the positive wire with the green LED, let's do that into pin number 3. There we go. Now that that's complete, take another 2 wires. You have your green, you have your red. I mean your white and then your red, sorry. And plug one of the wires into GND, should be highlighted on your microcontroller, right there. And plug this into the farthest negative power hole possible. So right here. Camera's pretty blurry. There. Let's do the same with this one. Take our wire, connect it into the positive end on our breadboard, into any positive power rail. Let's connect this end into 3.3 volts. If you do want to supply your components with any more power, with more power than what's going to be shown in the video, you can plug it into the 5 volt slot, but I wouldn't recommend that because parts might get damaged. Like I've already burned a couple of LEDs, red LEDs, making that mistake. Now, take our button, attach the button into here. Now, the button that I have transfers power to the diagonally opposite leg. So, if we connect power into the top right leg, like this, it's top right in my point of view, then the power will be transferred to the bottom left, right here. power starts from here, goes into here, and comes out from there, and it just drains out into wherever it needs to go to. Let's connect this end to any pin on the microcontroller that we want. Once again, I'll just do pin number 4, going up numerically. Let's plug our diagonally opposite end directly to negative, to any negative power pin on the power rails. Let's repeat the same steps with this buzzer. However, a buzzer does have polarity, so it really matters what direction you put it in. You have the long leg, which once again represents positive, just like your LEDs, and your little leg, your small one, that represents negative. Keep in mind what direction you put the positive and negative in. I'm putting the positive ends on the right side, my right. So, let's connect the positive end into any pin on the microcontroller that we want. I'll do pin number 5. Next numerically up number. So now here's the important part. The resistors I'm using, they're all 220 ohms, so it will make like a moderate beep sound. But if you want it to be a little louder, you can go less resistance. But if you want it to be a bit quieter, you could go with more resistance. I found that after around 2000 ohms, this resistor doesn't really make much audible sound. I mean, this buzzer doesn't make much audible sound. Just plug that in there. Plug the other end into negative. Like so. There we are. Final step. Let's rotate and plug in the cable that came with the microcontroller. This cable will come in handy later for uploading the code to the controller. Now let's get started with the coding.
Hey there, I hope the assembly process was easy for you. If anything was difficult or you didn't catch anything, feel free to rewind the video and slow it down. We've initialized all of our pins over here. Pin number 2 is the red LED, pin number 3 is our green LED, pin number 5 belongs to our buzzer, and pin number 4 is an input pin for our button. We're not done with the setup block. Usually what we do is we're going to just initialize the pins, but here we're going to have to do a little bit more. Let's create a Boolean variable, which is true or false, that tells us whether or not the button is being pressed down. So if it is true, means the button is currently being pressed down, and if it is false, the button is not being pressed down. Let's experiment with a new command today. Serial.print will print something to the serial monitor on your computer. So you could just print whatever messages you want. For now, let's put in some instructions on how to play the game. We've entered the reaction time tester. Now I'm just going to fill in the instructions really quick. Okay, now we've filled in the instructions. Right after we plug it in, right after we plug the microcontroller into our computer, we will see these instructions printed directly to the screen. Now, let's get going. Now, after this delay, let's turn the red light on. No, wait, turn the red light on here. Turn the red light on. Turn the red light off over here. Turn the green light on. And now here's the part where we're going to use our buzzer. If you remember, our buzzer is pin number 5. So now what we're going to have to do, buzzer's pin number 5. Let's turn it on. But we only want it to be a momentary beep, because it shouldn't be like beeping for the entire course of the amount of time it takes for the person to press. It should only be a beep for around 50 milliseconds. So let's give it a 50 milliseconds delay. Let's turn the pin right. directly off. Just right back off. It's only meant to be a short beep. Make sure to add semicolons everywhere, at the end of every line. Now we have completed our setup part. Let's just define one variable to take the time that we started at. Millis is a method in the C++ programming language that takes a time snapshot in the number of milliseconds. And because the Arduino script language is really similar to the C++ language, it's going to work the same. Let's create a Boolean variable that tells whether or not the button is being pressed or not. So this variable will be true if the button is being pressed, but it'll be false if it's not being pressed. Now, if btn, so whatever code is in here will only be executed while the button is being pressed down or after the button has been pressed. If it hasn't been pressed, nothing will happen. Let's define a variable. It takes another time snapshot of the time the button has been pressed at. Let's turn the green light off because they pressed the button already. And I'll turn the red light back on. Final variable, we're going to be taking the difference in time between the start and the end. So that tells us the amount of time that there's been between the green light turning on and the the green light turning on and the button being pressed. Let's create that. Make it duration is equal to end minus start. As simple as that. Now let's print our reaction time. Serial to print reaction time. Duration. Let's add a new line character, which is \n. If you notice over here, we've added \n as well. Otherwise, everything would print on the same horizontal line, which doesn't really look aesthetically pleasing. Now, to prevent the button press from being registered multiple times, let's add a delay of around 2 seconds, or 2000 milliseconds. So we're completely sure that nobody really holds down the button for 2 whole seconds. So we're not going to have a problem with multiple reaction times being outputted. Final thing, plug your microcontroller into your computer, reaching for the wire. Now it says Arduino Uno on COM3 not connected. Now let's just plug it in. The not connected message has disappeared. Make sure the correct device has been selected. It might show multiple other unknowns. Do not select those, just select whatever says Arduino Uno. These unknowns are probably something else that's connected into your computer, like a mouse or keyboard. Upload the code. Select the declaration. Hold on. Oh, there's an extra curly bracket there. Now let's get straight to testing.
If you've done the assembly steps and the programming correctly, you should have a working reaction time tester. So now it's not working yet because you need to plug it in the microcontroller just unplug it for now. Now we gotta open our serial monitor. Let's turn on the serial monitor. Now plug it in. 9600 baud rate. All the instructions come now. Reaction time 363 milliseconds. MS. Now, if we'd like to restart the game for some reason, we could always just press this little red button on the microcontroller. This restarts the code and executes the setup and loop again. Reaction time 114 milliseconds. That was a lot better. So now you could show this to your friends. It's a really cool small project. It's more complicated than anything we've done. Damn, 347. That's pretty terrible.